Hey there, Math 124 fans. Continuing this series on Math 124 Exam 1. I'm preparing for the exam. This one's going to be on derivatives and tangent lines. In terms of derivatives, you have a small collection of rules. You have this power rule, nx to the n minus 1. You have this exponential rule. You have this log rule. And you have 6 trig rules. And those you should remember in a certain order. Sine, I said sine but wrote tangent. So sine, tangent I usually write second, secant. And we do need to commit these to memory. So the derivative of this one is cosine. The derivative of this one is secant squared. The derivative of this one is secant tangent. And I always say if you can remember those 3, you can remember the rest. Because the ones that start with a C, I call this the Loveless law of the C's. Because it sounds like I'm a pirate or something. These all have a negative. And so I'm always mad when books don't arrange things this way. Sine of x. This is cosecant squared of x. This is cosecant cotangent. So honestly, I feel like if you can remember these, then you can remember them all. Beyond that, we have a few things. We have a coefficient rule, we have a sum rule, which basically says if there's a coefficient or sum, they just come along for the ride. And then we have product, quotient, and chain. So really beyond these rules, you have product, quotient, and chain. Okay, so let's recap how we do this. So step 1, in order to be a calculus student, is to be able to rewrite an expression like this as the following. 4x to the negative 2, 16x to the third. And some of these steps are unnecessary if you're already comfortable doing this. You can do all this. But you have to be able to identify what is a coefficient and what is the power. And if all you're dealing with is if there isn't an x in the numerator and denominator, I remember on this exam, there were a bunch of students that used the quotient rule on all 4 things. That was a huge waste of time. Okay, so anyways, coefficients come along for the ride, sums come along for the ride, and then you have 4 smaller jobs to do. Now, if you know how to do all that already, you don't need to write it in these excruciating steps. This is going to be power comes down, you subtract 1. So if I was writing that, I would have just written it on the go, meaning I would have written negative 8 x to the negative 3. And you can double check, did the power go down? Same thing here. If I bring that 3 down, it's going to be 3 6, which is just 1/2 x squared. Did the power go down? Yes. Exponential rule, there's actually a chain rule hidden in here, e to the negative x times the inside, which is negative 1. E to the x, done. So here we have a sum. The derivative of this is 0. And then so I should have first. My advice to students is to rewrite, separate the terms, and then say product, quotient, or chain. So let's rewrite this. I would rewrite this in any way I can simplify it, which would be this way. Secant of x minus 16. Separate our terms, but the derivative of that term is just 0, so that's kind of a non-issue. And then for this expression, which is a mixture of things, ask yourself product, quotient, or chain. It's a product rule, first and second. So we're going to do first times derivative of the second, that's secant, which we know is secant tangent, plus the derivative of the first, which is 9/2 x to the 1/2 times the second. And this needs to become routine. Next one, what do we do? Product, quotient, or chain. You could expand, but the chain rule takes care of it right away. The chain rule says you're taking the derivative of something that's squared, and the derivative of something that's squared is 2 blank to the 1. Then you take the derivative of the inside. But first you copy it down. So that's that chain rule you've been learning. Times the derivative of the inside. Now the inside is 3 minus 5 to the 1/3. And I'm sure you can find many resources in more excruciating detail than mine that explain this. What do we got? A product rule. So you would start applying the product rule. What do we got? A quotient rule. These are all from either my exams or exams of recent instructors. Denominator times root of the numerator minus numerator to the denominator all over the denominator squared. I tell students to fill in the pieces that require no thought and to visually always do it the same. You're like, okay, there's my denominator squared. If those two things don't match, I've messed up. And then write the numerator, so it's 3x minus 2. And then you just have two smaller jobs to do. The derivative of the numerator is 3. And hopefully in the homework, you've been building this routine. Okay, now tangent lines. Tangent lines are quick. To find the equation of a line, you need the slope, you need the x value, and you need the height. Part of the point of the tangent line questions is that by doing calculus, you've learned how to find those things quickly. I have a function. I know its derivative, 12x squared minus 14x. This represents the height. This represents the slope. And then they hand you the number x equals 2. So these are extremely straightforward questions. So your height would be 2 cubed minus 7. I guess we have a little calculation to talk about. I don't want to do, I don't know why, but I want to factor out a 4. That's going to leave me 2 cubed minus 7. Aha! I knew that would be better. That's 4 minus 4 times 8 minus 1, which is 4. So I always like to try to factor or cancel if there's any way for me to do it, because I don't like to pull a calculator out. Okay, so 12, 2 squared minus 14 times 2. If you want to try again, you could see what you can factor out. But I already can see I can factor a 2 out, so let's do that. That's going to leave me 12 times 2, which is 24 minus 14, so it's 20. That's a thing people don't often do. They get so reliant on their calculator. But anyways, that's a different story for another day. Find the equation for the tangent line here. I think these are fairly straightforward. You know, you're just looking for these three numbers. This should be a piece of cake. Well, it's funny they gave you the 3 already, because you'd have to 8 minus 6. Okay, that's it. All you have to do is take the derivative. Y prime is 3x squared minus 3. Plug in a 2. You're going to get 12 minus 3 is 9. All right, these aren't that exciting. I'm going to keep going. Here's a question from a different instructor. Find the equation of the tangent line to this graph at this point. Again, they tell you the value. It's -1. There's a half. And so there's just one thing to figure out, which is the slope. And they told you the slope too. So all you got to do is plug in -1. This is an extremely fast question. 2 over 2 squared. It's a half. Done. Find all points where the tangent line has slope 2. Okay, so it's asking when is this 2. And so that looks bad initially, but we're going to clear the denominator before we panic and hope that we can solve this thing. And I can cancel a 2. Ooh. Slope of the tangent line has 2. Minus x equals 1 plus x squared squared. Well, that can't happen. Is the answer to this no solution? Oh, where the tangent line doesn't have slope 2, has x-intercept 2. See, I got to read carefully. This just proves I didn't prepare for the video. All points where the tangent line has x-intercept 2. So that's a different question, really, for a different part of this. Because I'm going to talk about applied tangent questions in a different section, so I might bail out here. But they're telling you this about the line, and they're telling you the slope of the tangent line, so you have a bunch of things you can say. You just don't know what this x value is. Oh, but you do know it goes to the point 2. Well, that's another video. Okay, let's stop there. I think that's enough with the